Hello and welcome to another LeetCode video. Today we're going to be doing problem number 61, rotate list. And I think this problem is cool because it teaches you how to rotate a linked list, which is going to be a subproblem for other problems, and it's pretty rare to do this kind of thing, so I wanted to go over it today. And so the problem is, given the head of a linked list, rotate the list to the right by k places. So if you're given a linked list like this, then you want to rotate it to the right, so it's telling you by 2 places. So what do you actually do for a rotation? Well, you just take the element at the end and you put it in the front. So it would be something like this. So this would be one rotation where you just put a 5 in the front. And then we have one more rotation where we put the 4 over here. And so our new list is going to be 4, 5, 1, 2, 3. That's a rotation. Now let's look at example 2. So we have this 0, 1, 2. Now also quickly know that if the linked list is 3 length and you rotate it by 4, well, like what does a 3 rotation look like, right? So let's just take a look at that first of all. Let's just look at like 1 rotation, 2 rotation, and so on. So for 1 rotation, so let me just I'm just gonna write like this is 0 rotations. For 1 rotation, we're gonna put the 2 in the front. For 2 rotations, 1, 2, 0. 3 rotations. So notice how for 3 rotations, it's actually the same as the original list. So when you rotate something that more than the length of the list times, you're pretty much starting over. And so if the list length is 3 and you rotate it 4 times, it's really like rotating it 1 time. So if you rotate it 1 more time, then it would be this right here. And so that is something important. So if you have a list length 3 and you rotate something by 1,000 times, you can just mod it by 3 to figure out what your rotation is. So that's one thing, you know. Now another thing, if you actually take a look, well, it's actually pretty easy to do rotation, and this is how you would do it. So let me show you. So let's say we take this original list of this. It's actually pretty straightforward. We can do a 1 pass to get the length, right? Just start at the first node, go to the end. Then once we're at the end, all we have to actually do is connect this end node to the front. And now, if you think about it, now to rotate a linked list, no matter how many rotations, all we have to do is just chop some next pointer. So for example, let's say we want to rotate it twice. Well, what would that look like? Then we want it to end with a 3. All we do is chop off this. And if we chop off this, then it will be 4, 5, 1, 2, 3. And so the basis of this problem is going to be to figure out how many elements are in the list. So let's just call that n. To make the next pointer of the tail go to the head. And then we just have to figure out where to chop. So if the list is length n and we have to rotate k times, where do we actually have to chop? Well, let's think about this. So for length 5, if k equals 2, what node do we have to be at? Like, let's say we start at this node. What node do we actually have to be at? Well, we have to be at this node. So we actually have to move up 2 nodes. So if k equals 5 and n equals 5 and k equals 2, we have to move up 2 nodes. So what would that be? That would actually be n minus k, right? Minus 1. If we start at this starting node. Let's try another value. Let's say we want to rotate it 4 times, right? So n equals 5, k equals 4. So what would 4 rotations look like? Well, you would think this would go in the front, this would go in the front, this would go in the front, and this would go in the front. So the list, what you want the list to look like is 2, 3, 4, 5, 1. That's 4 rotations. Because if you think about it, 5 rotations is the list being entirely the same, and that would happen, right? If you do 1 more rotation, then this one would go into the front. And so that would be that. Okay, so if you want a list like this, where do we have to chop? Well, we want 2 to be in the front, so we have to chop, let's see, yeah, right here, right? We want 2 to be at the front. So wherever we chop, that's going to be our new head node. Okay, so if we want that to be there, then how many nodes do we have to travel from the start? Well, we actually have to travel 0 nodes. And so once again, that's n minus k minus 1, right? 5 minus 4 minus 1. And so the trick to this problem is honestly figuring out that, you know, rotating more than the length times is just doing the same thing over again, and then figuring out actually what's the formula to chop. And this is going to be the formula to chop. It's going to be n minus k minus 1. And like I said, for these linked list problems, if you can't figure this out, just try a couple examples, see what like it should be, and then make sure it, try like 3 or 4 examples, and then try your formula, and then just count it up and make sure it makes sense. And in this case, it does. So this is going to be our rotation formula. Now all we have to do is get a length. We have to make this tail point to the head, and then we just have to go to the right place and make a chop, and then we also have to return the new head. So before we make a chop, let's say we make a chop here, we're at this node, we just have to save this node to be our return value, right? Because we have to return the new head of the list. Okay, so that's pretty much all for this problem, so let's code that up. So there are a couple things, I think. So the number of nodes can be 0. So we can just say if not head, we don't have to do any of that, we just return none. Okay, now let's get our k value, but let's actually mod it by the length, but let's actually get the length first, right? So we'll just call this like length list equals 0, cur equals head. Let's make cur equals head, and then we're actually going to set the list length to 1 in this case because we don't, so normally what I do is I set the cur to some node and then I keep doing it while cur doesn't equal none, but we actually want to make sure that cur.next equals none when we stop because we actually do want to save that tail node so we can connect it to the head. So what we can do then is while cur.next instead of cur, then we can just do, we can move the node up, so we can do cur equals cur.next. We can do length list plus equals 1, and then that would add 1 to the list. And now this will stop when we're at the tail node. So then we just do cur.next equals head. So now the head and the tail are connected. Okay, so now we have to figure out where to chop. And so let's actually update our k. So our k is going to be k mod length list. And then we can just call this like chop spot or something equals n minus k. It's not n, right? It's actually length list minus k minus 1. And so this is how many times we move forward. So we can just say like while chop spot. We also need to set the cur to the head. So we need to start over and we need to move from the head. So while chop spot cur equals cur.next chop spot minus equals 1. So now we are at the spot we need to chop. Now we need to update our head, and then we just need to chop. So head equals cur.next, and now we need to chop. So cur.next equals none. We made our chop, and then we just need to return the head. Okay. See. All right, cool. So that's how you do this problem. Now let's think of the time and space complexity here. And for these kinds of problems, because they are like, people have really efficient solutions, there might be something that's like a 1-pass instead of a 2-pass or things like that. I don't know if you can do it in a 1-pass. Yeah, I don't think you can do it in the 1-pass because you can't like chop like before you make the connection. What you might be able to do to make it a little bit more efficient is like move. You could figure out, is it faster to move? No, you can't really move backwards either. Yeah, so honestly, I'm not sure how to make it too efficient. There might be some other algorithm, but this is like, I think actually time and space wise, this is as efficient as it gets. You're not going to be able to do this in like log n or anything. Okay, so now let us figure out the time and space here. So the time, so we do go through, this is going to be a 2-pass, so this is n. We are just going through the linked list twice. And then space, we didn't actually make any extra, like nodes or anything. We just have a link to the list and like chop spot and things like that. But those are just constant variables. That's going to be constant time. Okay, so that's it for this problem. Hopefully you learned something new. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.